Now it is fine, sir. Sir, you can
Yeah,
continue.
I thought it is shared. Okay. Uh, so LiDAR technologies, it's active remote sensing technology. Why it is active remote sensing technology? Because so especially in remote sensing techniques, we use a sunlight. Okay. So that is actually passive remote sensing technology. But here LiDAR is an active remote sensing technology. In fact, it eliminates the light. It eliminates the target with a laser and analyzes the reflected light. This is called actually. This is how it happens. Even radar is also active. Remote sensing technology. What we are using is a passive technology, and this is LiDAR technology is active remote sensing technology. Okay, it's almost similar to the radar and hydrography. It uses a light pulses instead of radio waves. Okay. Uh, so in light pulses, they are not using all electromagnetic spectrum area. We use it for a different end user. We will be using a different electromagnetic spectrum of a some portion of the visible region, some portion of the near infrared region, some portion of the UV region also we use. So probably you must be knowing about this electromagnetic spectrum. I'm not going into very details. I'll just show you one this thing. So what is the advantage of this technology? Is it actually eliminating the target with a laser beam and generate 3D points, 3D cloud points of a target and its surroundings. This is the biggest advantage. See, when you are using a scanner or your scanner is also same, but if you are using a your robotic ETS and ETS, we target to particular point. We only get the position of that portion, that target. But whereas it's not like this in LiDAR technology. Surrounding area also we get a information position as well as the illumination light, everything we get it. Hello. Okay, so what type of information we can gather from this is actually one is topographic information, that is arranged to the target, we can get it, and chemical properties of the target. So we can also get due to differential absorption, we can also get a chemical properties of the targets. So like you can find out um, plant health, okay, crop health, and then there are many other things we can get it from this one. Let's see that what all the things we can go slowly. So this is same like a hydrography. So we have, instead of boat, we are using here for a laser. I mean, a flight as well as a drones or whatever it may be, or even balloons or whatever it may be. There also we are using a GPS. There also we are using a IMU. Here also we have a same. GPS is there, IMU is there. Here we have a laser scanners. Scanners are there. Here we are using a light pulses, and that is a either UV and other things. So we get a points, and scanning methods are different. Some technologies scanning zigzag scanning, some elliptical scanning is there, some circular scanning is there. Only scanning technology, that depends on what purpose you are doing the survey. Based on that, we can change the scanning methodology, scanning techniques. All other things will be same, almost like a hydrographic survey, multi-beam survey. So, what all the components present in this LiDAR's scanning unit? What that's called actually trans receiver and scanners. So, what it gives is trans receivers will send the light, and then scanner will receive the it will scan, and then internal inertial measurement unit, IMU we call it. So this probably last section somebody asked me how it will. So I will go a little bit detail in this one. And the global positioning system is there, and data recorder will be there. Thus a small computer will be there. Everything will be linked to that one, and then all the data will be stored in the our computer. and associated electronic drives will be there. In that, data will be stored. See, somebody was asking me what is IMU. So I'll just run a small video actually. See, when the flight is moving, roll is actually uh, clockwise direction or anti-clockwise direction of front portion. Yeah, in this direction. Pitch will be this direction. Just check it. Hope you got it. Why we need to get IMU? IMU. What is the importance of IMU also? This is the block diagram of entire setup actually. As I said, here also transmission is there, okay, and then the data acquisition unit will be there. Chiller will be there. We have different types of chillers in our. We have air cooled chillers are there in our flight especially. Laser power. We have our separate generators will be there to connect it, and then we have a PC connected with the cameras, and then data will be stored in the tapes as well as nowadays uh, hard disk. Directly we can store it in a hard disk, and the receiver will receive. Laser will send the beams. Receiver will receive. Received data will be stored in the PC, and then we use a GPS and IMU data to rectify our data. So this is the entire setup of the block diagram of the entire setup. So as I said, how it works actually, it laser produces optical pulses. So these pulses pass through the atmosphere and hit the target and return to the receiver. The same thing, same like that. Receivers automatically measure the time taken. So with this, we can get the elevation of the target. If you combine this with the GPS coordinates and with IMU, we can also get exact position of each target and uh, other information. What other information we'll get it, we'll see that later. So I was telling normally, especially for hydrographic survey, we use blue green as well as the near infrared. Okay, in the hydrographic survey, whereas in our land we use a visible as well as UV also we use, infrared also some scanners we use ultraviolet, visible and infrared. So these are all the things, especially in this one, red, sorry, blue and green along with the near infrared reason of the ultramagnetic spectrum. We use it for bathymetry as well as terrestrial scanners. This one, I think, hope everybody knows about electromagnetic spectrum. I don't want to cover it. Why people are using LiDAR is they have a high resolution, because as you already know that we can get even 5 centimeter accuracy data. Okay, resolution is also very good. Spatial resolution is 5 centimeter. Any object we can identify 5 centimeter object on the Earth surface, and they are more accurate, and it will cover a broad area. since we are doing the survey with a higher altitude, uh, it will cover a more area, and it's a scalable also. It's a cost effective only because if we are doing the survey for the large area, we can use, this is the best method, best technology, best methodology. Okay, and we can also get a multiple products. Okay, so some people are interested only elevation, you can get it. One survey, you can get lots of information. That I will show you what are the products you can get it. And some people are interested only elevation, so you can also get it. Some of them are interested in some other, so you can get. And also it will produce a multiple format, many formats. So uh, it, this data, raw data, can be used in a uh, different softwares. That is another advantage why people are prefer to use a LiDAR technologies. We can use it in a different formats, and also we can get a lot of information. Whereas in aerial photography, what we can get is only mapping and elevation we can make it. But here it's not like that. We can get many information from out of LiDAR survey. That's why now aerial photography completely vanished. There is no technology now. Nobody is using aerial photography techniques. Everybody started using a LiDAR techniques. So, okay, I'll just go a little bit how these pulses are, what is the frequency and what are those things. So, olden days, they used to use a few thousand pulse per second. Now, what they are using is almost 167 kilohertz uh, pulse they are using. Now, modern systems are also capable of recording this one. As we all know that as the frequency increases, you get a more accurate and more data, more information. But only one problem is that penetration will be less. That's why what we are using is most of the times during survey techniques, from 71 to 100 hertz frequency we use it for survey. Wherever 71 frequency kilohertz frequency we use, less than that one, so it will penetrating range will be more, and you will get a less information. If you use a more kilohertz, you will get a more data, less more information, but less penetration will be there. This technology we use it for a different height measurement, okay, penetration method, elevation, evaluation method, all these things will be using. Okay, the density of the discrete returns were obtained in a proportional to the scanning frequency. So as I said, so different scanners frequency we use, we get a different reflections. So the system operating at a 150 kilohertz on board will generate a much higher number of returns than when operating with a 71 kilohertz. That's what I was telling. So that's what. So before planning the survey, you should know what is the requirement, your data. Okay, nowadays in our new technology has come now. We have two simultaneously. We can connect two sensors in a one unit. Okay, or we can, so we are doing it for especially coastal region. We are doing it for a blue bathymetric survey as well as a terrestrial survey, topo survey also we are doing it. At a time we did it for a survey of India for entire Indian coast, so 7,100 kilometers, something like that. So we use that technology. So we are using a same data for a bathymetry, and also we use it for extracting the coastal region around 50-kilometer region. We extracted the topographic information. So it all depends on what purpose and area coverage to choose frequency. That's a very important thing actually. So LiDAR platforms. So LiDAR platforms, there are different platforms we are using it. First one is earlier I said, so like terrestrial scanners are there. So as soon of this ETS replaced with the terrestrial scanners. These scanners they used to do it for monument survey, building surveys, and then to cover big buildings, interior designing, all those things they used to do with a terrestrial scanners. We also did uh, when 2013, 2014, We did Shivalaya temples and some few churches, and in UK and other places we did. So we also have this one, but nowadays this technology is also outdated almost. So we use these instruments nowadays. After that, car mounted laser scanners started coming. uh, Believe it or not, olden days when we were doing the survey, to measure 1 kilometer road survey, almost I mean per day we used to measure almost 4 kilometers, just 4 kilometers. Or if you want to do carry elevation from one place to other place, so whole day we have to do the survey. We can cover only 4 kilometers, 3 kilometers sometimes. Okay, now imagine if you just fix these cameras on the car, just go almost 60 100 kilometers we can cover in one day. Okay, and that ETS method, hardly we used to cover around 1000 2000 maximum objects in a day. But here in 100 kilometer we can cover in a day. We can also cover day and night also. We can also get all surrounding objects which are visible to the scanners. We can get the information. That is the beauty of laser scanners. And then satellites also we have. There are some satellite scanners, laser scanners also there, radar scanners also there. And when you fix it on the flights, we use it in the flights also. IAC is having two flights, so they both are IIT VT IAC is there. So here also we have a this same flight will be using it for a aerial photography as well as a lidar survey and drone survey also. Drone survey, if you want to cover a less area, so we can use the drone technology. Suppose if you want to use it for a more area, we will go with the flights. Only disadvantage with the flights is very costly affair. Okay, and also you require a lot of permission, DGC approvals you required. And you should also get if you are doing a border surveys and all, gone case, it takes minimum three to 4 months to get a permission. But so in that case what we use is drones. So drones also, there are lots of restrictions also there. Nowadays, nobody cares about these restrictions. When you go with LiDAR training programs, they will teach you. So you are not supposed to fly the drones wherever the people are there, wherever the cattle are there. But nobody cares about that one now. Everywhere drones are travel and drones are flying. So actually, drones, there are lots of advantages there, lots of disadvantages also there. And another one, if it is fixed on the boat or in this one, so battery later also you get it. So these are all the different platforms available presently with the same LiDAR technology. So almost six platforms are nowadays they are using it. Is it followable? Okay. Yeah. I just wanted to, since I am in a, I'm a marine, so I normally cover more about a marine. So battery LiDAR, it's a more advanced technology, we can say. Uh, uh, to cover a Red Sea area, we did a Red Sea survey for the entire Red Sea. We took almost 3 years. 3 years we covered with a hydrographic survey, multi-beam survey. We covered 3 years to do the survey. But whereas Persian Gulf, entire Persian Gulf, we covered it in just 13 days. But another disadvantage with this bathy lidar is we cannot do deeper motion. It will penetrate up to 50-meter depth only we can get it. So beyond that, this technology cannot be used. Okay. So this is the best convention when it compared to the conventional techniques. This is the best survey methodology for getting the near shore features to cover regularly. This is the best methodology, and also data processing also very quick we can make it. So we use a blue green portion of the spectrum and also IR. So why we use a blue green and IR is actually blue green will penetrate into the water and hit the surface and get back to us with a reflected information. But infrared will give the water surface. So you know that what is the difference. So you can calculate easily what is the water depth. Okay, since we have a GPS, and then I mean, light will be reflected back from the water surface as well as the bottom of the sea. So you can easily calculate the depth. But here again, there is one more problem is there. If the water is clear, you can even go up to 70 meter depth. If water is not clear, we cannot even penetrate up to 15, 20, 30-meter depth. Red Sea, it was very good. Even Persian Gulf also very good because their rivers are very less rivers. So water was very clear. There was no problem. Okay, and even in Lakshadweep Islands and these places also we did the survey. So we got a very good result when compared to your bathymetry. Now we are doing entire Ganga using a lidar techniques because in a harsh condition, moving the ship is also very difficult, and mobilizing the ship is also very difficult.